Good morning. Happy Monday morning. I'm Steve.
And I'm Scott.
And together we're Backyard Musings, broadcasting live from Apple Valley, California.
And we are the Science and Technology Channel.
Yes, sir. Very strange one today, isn't it?
I like this one.
Huh.
This is a good one because this is, we're in snake country here, so
yeah,
this is good.
Scientists have developed a potentially universal antivenom using antibodies from a hyperimmune human donor. You heard that right.
This is weird.
Yeah, weird. Offering broad protection against deadly snake species and a major leap forward for snakebite treatment, scientists have developed the most broadly effective venom ever created. It protects against some of the world's deadliest snakes, including the black mamba. The black mamba is certain death, right? King cobra and tiger snake, at least in promising early mouse trials.
We like the mouse trials.
We do. Would you like to know more?
Published in the journal Cell on May 2nd of this year, 2025, the study introduces a next-generation antivenom made using antibodies from a remarkable human donor.
From a human donor.
Yeah. This new formula blends those powerful antibodies with a small molecule inhibitor, opening the door to what could one day be a universal treatment for venomous snakes.
Okay.
Now, we don't have any of those snakes that you listed there, but we
mamba?
do have.
No, that's Africa.
Right, but we do have rattlesnakes here.
Yeah.
Several species.
But Australia has some of the most deadly down under.
Yeah.
For over a century, the process of making antivenom has remained largely the same. It typically involves injecting horses or sheep, oh, that's so cool, with venom from a single species, then collecting the antibodies the animals produce. While this method can work, it often triggers immune reactions in humans and only protects against specific snakes from specific regions. That is like archaic, man.
Well, I think they use those animals because I think those animals are kind of have like a built-in immunity to that. Horses or like even dogs, I've heard, and cats have like a built-in immunity. I'm not total, but
can you imagine walking up to the horse with that snake and the snake bites the horse?
Yeah, or maybe they just inject them with the venom,
Yeah, maybe they milk the venom and then they inject them. Okay, all
right. In search of a better solution, scientists stumbled upon someone hyper immune to the effects of snake neurotoxins. Quote, the donor, for a period of nearly 18 years, had undertaken hundreds of bites and self-immunizations with escalating doses from 16 species of lethal snakes that would normally kill a horse. Now this I don't get.
Snake man.
You would do that. Exactly. And this is said by the first author, Jacob Glanville, CEO of Cenovax Incorporated.
No, why would this dude do that?
I don't know.
And it says undertaken. That's
this would be
not
something.
By accident.
You remember the guy that had the show? He was from Australia. He had that show.
Steve Irwin. Right?
Yeah, Steve Irwin. He died, right?
Yeah,
he got bit by something.
No, he got punctured by a manta ray or whatever.
Oh, okay.
Stingray.
Okay.
He got punctured right in the chest, man.
Okay.
What a gruesome way to go.
But he had to get bit by other animals, right? Because he was always messing with that kind of stuff.
I would think so, yeah.
Yeah, so maybe this guy's kind of like that guy, but bless him for doing this because it's going to help.
He's a snake whisperer.
Help people out, yeah.
Right?
Yeah.
After the donor, Tim Freed, agreed to participate in the study, but we said his name because it was in the report. So,
yeah.
We
don't know anything about the guy.
We
don't know his phone number or address or anything.
We're not going to dox him.
Yeah, we're not.
Researchers found that by exposing himself to the venom of various snakes over several years, he had generated antibodies that were effective against several snake neurotoxins at once. Do not try this at home or anywhere else.
Yeah.
That's what I put in there.
Okay, quote, what was exciting about the donor was his once-in-a-lifetime unique immune history, says Glanville. Going on with the quote, not only did he potentially create these broadly neutralizing antibodies, in this case, it could give rise to a broad spectrum or universal antivenom.
To build the antivenom, the team first created a testing panel with 19 of the World Health Organization's Category 1 and 2 deadliest snakes across the Elapid family. Elapid, E-L-A-P-I-D family. A group which contains roughly half of all venomous species, including coral snakes, mambas, certain death, cobras, taipans, and kraits, Kraits. Never heard of that.
I've heard of cobras, mambas, and coral snakes, but I've never heard of
Taipans and
the other
kraits.
ones. Yeah.
No, that might be interesting. Google that and see what they look like,
Yeah.
or where they come from.
Yeah.
Next, researchers isolated target antibodies from the donor's blood that reacted with the neurotoxins found within the snake species tested. One by one, the antibodies were tested in mice and venomated from each species included in the panel. In this way, scientists could systematically build a cocktail comprising a minimum but sufficient number of components to render all the venoms ineffective.
The team formulated a mixture comprising 3 major components: 2 antibodies isolated from the donor and a small molecule. The first donor antibody, called LNXD09, I think that's a 0, protected mice from a lethal dose of whole venom from 6 of the snake species present in the panel. To strengthen the antiserum further, the team added the small molecule varespledid, a known toxin inhibitor, which granted protection against an additional 3 species. Finally, they added a second antibody isolated from the donor called SNXB03, which extended protection across the full panel.
Oh, it's like genetic manipulation here to help you out.
Yeah.
Quote, by the time we reached 3 components, we had a dramatically unparalleled breadth of full protection for 13 of the 19 species, and then partial protection for the remaining that we looked at, says Glanville. He continues on, we were looking down at our list and thought, what's that 4th agent? And if we could neutralize that, do we get further protection? Even without a 4th agent, their results suggest that the 3-part cocktail could be effective against many other, if not most, elapid snakes not tested in this study.
With the antivenom cocktail proving effective in mouse models, the team now looks to test its efficacy out in the field, beginning by providing the antivenom to dogs brought into veterinary clinics for snake bites in Australia. Yeah. Further, they wish to develop an antivenom targeting the other major snake family, the vipers.
Vipers.
Ooh. Yeah.
Vipers have triangular heads. Quote, we're turning the crank now, setting up reagents to go through this interactive process of saying, what's the minimum sufficient cocktail to provide broad protection against venom from the viperids, says lead author Peter Kwong, Richard J. Stock, professor of medical sciences at Columbia University Vagelos College of Physicians and Surgeons, and formerly the National Institutes of Health. Quote,
NIH.
Yeah, that's a big, put that on your business card.
Yeah.
Quote, the final contemplated product would be a single pan-antivenom cocktail, or we potentially would make 2, one that is for the elapids and another that is for the viperids, because some areas of the world only have one or the other.
The other major goal is to approach philanthropic foundations. Did I get that right?
Yeah.
Philanthropic. Governments and pharmaceutical companies to support the manufacturing and clinical development of the broad-spectrum antivenom. Quote, this is critical because although there are millions of snake envenomations per year, the majority of those are in the developing world, disproportionately affecting rural communities, Glanville says.
Understand that completely. But yeah, just having this on hand at the clinic, just
or on
when you're hiking,
a life flight helicopter.
Oh yeah.
Because like in our case here, I've lived in the desert almost my entire life, and I've come into contact with snakes. Fortunately, never.
Have you been beguiled by any snakes?
I've never. Well, not snakes that I've come across in the field, but the ones that I have come across, fortunately, haven't been aggressive. And I will have to say, 1 or 2 of those snakes have, unfortunately, been taken out of. They've been taken out. Yeah, they've been 86. So, but for the most part, there hasn't been any kind of an issue. But there, in some of these areas where I've had contact, if I had been bit, it probably would have been lethal because I would
kiss your rear end goodbye.
Yeah, I was not near my car or my vehicle. I was with people, but there's no way that I would have been able to get out of there without some kind of, flying out by helicopter or an ambulance coming into the backcountry. So
Or
have
some
something
dude
like
putting you on
this.
his back and running to safety.
Yeah.
Yeah, it didn't
So,
have that.
and I remember when I was little and we would go camping, or my dad and I would go camping or fishing, he had this little tiny snakebite kit.
Oh,
And it had like a tourniquet in it, and it had some blades, and it had some, I forget, I think it was like some kind of ointment, but I don't remember what it was. But it was, and gauze and stuff. But, you know, again, this is cool to where you could carry this in a first aid kit or in your backpack.
and it works for most species.
Right.
Yeah.
And it would be better than the alternative, which would be either getting carried out, because you're not supposed to move, right? If you're bit by a snake, you're
Right,
not
because
supposed
that
to
just
move because it circulates the
through
venom.
the body
So,
quicker. Just
so yeah,
basically, you want to gnaw off the portion that gets bit. Like you want to gnaw it completely off so that it doesn't get to right.
The people
Huh?
that I've been with, when I could have happened, I'm sure they wouldn't have done that. They would have just said,
Hey,
"I do."
you got to do what you got to do, man. You want to survive, you got to bite that leg off.
Yeah, send up a flare. We'll get back to you when we can. Anyway,
All right, folks.
great topic. So
Yeah, thanks for joining us.
take
We'll
care,
talk to you
everyone.
later.
We'll see you later.